Welcome back, students. We are already familiar with the phenomena of refraction, which is bending of light when it passes from one optical medium to another. Our atmosphere is also made up of air, which has different densities at different heights. Near the surface of Earth, air is denser, and as we move upwards, air becomes rarer. So therefore, the sun's rays on entering the atmosphere of Earth, they move from rarer to denser medium and they keep bending towards the normal. And this phenomena is called as atmospheric refraction. And due to this atmospheric refraction, we witness many daily phenomena, and most beautiful of them all is rainbow formation. But before we see the rainbow formation, we want to know this term, total internal reflection. So let's understand this term first. Total internal reflection occurs when light moves from a denser to the rarer medium. Now let's see how. This is the incident ray which is traveling in the denser medium. At the interface, it moves into the rarer medium and bends away from the normal. So we can see this is angle of incidence, this is angle of refraction. If we increase the angle of incidence, angle of refraction will also increase. On further increasing angle of incidence, angle of refraction further increases. So if we notice, on increasing the angle of incidence, angle of refraction or the refracted ray is moving towards the interface. Now on further increasing angle of incidence, this refracted ray will go along the interface. That is, angle of refraction is now 90 degree. So this angle of incidence for which angle of refraction is 90 degree, we call it as critical angle. Now can you guess, if angle of incidence is made larger than the critical angle, then what will happen to this refracted ray? Yes, obviously it will enter back into the same denser medium. So this is incident angle which is larger than the critical angle. In this case, refracted ray will not enter into the rarer medium, but it will come back into the denser medium. And this phenomena is called as total internal reflection. This phenomena is of utmost importance because it is used for making many things, and one of that is optical fibers. Otherwise, light can travel only along a straight line path. But in the optical fibers, light is made to travel in the curved fibers. Let's see the internal structure of these fibers. It is made up of three main things. A is the core of the optical fiber, which is made up of special quality glass of higher refractive index. On both sides of this core is this B part, which is another medium of lower refractive index, so that light can move from denser to rarer medium. And then C is the protective covering all around this optical fiber. These optical fibers are used in medical in the process of endoscopy. Now in endoscopy, what happens, these optical fibers are sent down through the throat of a person into the internal organs to view the internal structure, just like the stomach. So it illuminates the internal organs so that they can be seen. With one set of optical fibers, illumination is done, and with another set of fibers, we get the images. So whether if there is any kind of inflammation or any other thing inside the stomach or any other internal organ, it can be easily viewed from outside. Light enters from one side of the optical fiber into the denser medium and it moves towards the rarer medium. It falls at an angle which is greater than the critical angle, so as a result it comes back into the same medium. Again here total internal reflection occurs. At this point again total internal reflection occurs. As a result, these light rays keep moving in the forward direction and come out from the other end of the optical fiber. So now we are ready to understand the formation of rainbow in the sky. We mostly see rainbows just after a rain shower because at that time there are tiny droplets of water in the air and they behave as small prisms. Apart from water droplets, there should be sun also out in the sky and it should be behind our back. Incident rays that come from the sun, when they fall on these tiny droplets which are behaving as prisms, from here their medium changes, so they travel from rarer into the denser medium of water. So here path will change or refraction will occur. But one more thing happens here. Inside the water, the 7 colors of 7 wavelengths present in the white light of the sun, they travel with different speeds and follow different paths. As a result, they split up into 7 colors. So apart from refraction at this point, dispersion into 7 colors also occur. So these 7 colors fall on this surface, and from here they do not come out this side because they are falling at the surface at an angle which is larger than the critical angle. As a result, total internal reflection occurs and these rays come back on this side. From here, when they reach this surface, again they will move from denser to the rarer medium and their path will change further. These rays on entering our eyes appear in the form of rainbow. So we are able to see 7 colors of the rainbow. Red color is towards the top and violet color is towards the bottom of the arch-shaped rainbow. Now we will first discuss these 3 positions, position 1, 2 and 3. What is happening at these 3 positions? So we have seen that at position 1, refraction and dispersion occurs. At position 2, total internal reflection is taking place, and at position 3 again, refraction of light is taking place. So we see rainbow just after a rain shower when sun is out in the sky. This rainbow always appears in the form of a semicircle or in the form of an arch. The reason for that is only those refracted rays are reaching our eyes that make an angle of 41 to 42 degree with this incident ray. From rest of the water droplets, rays are not reaching our eyes. So as a result, rainbow appears either in the form of a semicircle or in the form of an arch if we are standing on the surface of the ground. Suppose if we are standing somewhere in the middle of the sky, maybe we are sitting in an aeroplane. At that time, this rainbow will appear in the form of a complete circle. So this is how a rainbow is formed. This rainbow is called as primary rainbow. Red color is towards the outer surface of the arch and violet color is towards the innermost surface of the arch. So we have just seen the 2 important conditions for the rainbow formation are there should be tiny droplets of water in the sky which behave as prisms, and there should be sun out in the sky and should be behind our back. Let's see once again how atmospheric refraction occurs. So our atmosphere has different layers of air which have different densities. So when rays of sun enter our atmosphere, they move from rarer to the denser medium and keep bending towards the normal. So as a result of this, we can witness many optical illusions, and one of those is apparent position of stars. Wherever the actually stars are present, we never see them there. We always see them at some other position, which is called as apparent position of stars. Now let's understand why. So when the light from this star is entering our atmosphere, which has different densities of air at different heights. So at the highest part, density is lesser, then density becomes more and furthermore, which means that this ray is entering from rarer to denser medium. At the change of density, it bends towards the normal. Whenever then there is next change of density, it further bends towards the normal and then further depends upon the normal and reaches our eyes. Our eyes cannot perceive this bend path. It can only see the straight line path. So this last ray which is entering our eyes, so to our eyes the star appears here to us, which is the apparent position. So due to this atmospheric refraction, stars appear at the apparent position which is always higher than its actual position. We have understood that whenever light is moving through the air of different densities, it keeps on bending or changing its path whenever there is change of density. But the point here is that our air is not stationary thing. It is constantly moving. And if it is constantly moving, it cannot have a fixed density at a fixed height. So at a particular height also, density of air keeps on changing. And the consequence of that is the path of light at a particular height also changes. Sometimes if the density at that height is more, bending will be more and its path will be this. If next second there is different air there because it is flowing and that has slightly lesser density. So in this case, bending will be lesser and its path will be different. So initially this light was reaching our eyes, but now because it has changed its path because of the change of density, so the same light will not reach us. This gives rise to another beautiful phenomenon, that is twinkling of stars. Now twinkling of stars occur because stars are very far away from us and they behave as point objects. Means very few rays of light are coming from star and reaching our eyes. So those few rays may reach us at one point of time and next second some of them may not reach us because of the change of density of the air which is in between. So sometimes light that falls in our eyes is bright and at other times it will faint. It will be fainter. So light entering our eyes fluctuates. This gives rise to the twinkling effect of the stars. Unlike the stars, planets do not twinkle. It is because they are present very close to our Earth and behave as large sized or the finite sized objects. We can also say they are the collection of many point sized objects. So just as we have seen in case of stars, if light from a planet is coming from one point, it is reaching us at one point of time and the next moment the rays from the same point may not reach our eyes because of the reason that the air in between is constantly flowing or moving and its density is also constantly changing. So bending and path of light is also changing. But if light from one point is not reaching us, at the same time light from some other point may reach our eyes. As a result, if light from one point is dimmer, light from some other point may be bright, and this nullifies each other's effect and brightness of planet remains constant at all the times. That is the reason planets do not show any twinkling effect. Another interesting phenomena of atmospheric refraction is that our day becomes longer by 4 minutes every day, 2 minutes in the morning and 2 minutes in the evening during the sunset. So let's see what happens during the sunset. When the sun is already below the horizon, the rays of the sun which are traveling towards the surface of the earth, because it is moving from rarer to denser medium, it keeps on bending towards the normal and reach our eyes. But because our eyes cannot see this bent path, it can see only the straight line path. So the sun appears here to our eyes, which is the apparent position. So even 2 minutes after the sun has already set below the horizon, it remains visible to us. Same thing happens during the morning. Sun is still below the horizon. It has not come up, but because the rays reach the earth and to our eyes, rays appear to be coming from this point. So 2 minutes before sun is up, we can already see it. That is why a day becomes longer by 4 minutes due to the atmospheric refraction. Rays of light from sun move from rarer to the denser medium and they keep bending towards the normal, and sun, which is below the horizon, appears above it. So that is all for today's video. We have discussed about the atmospheric refraction and we will continue in the next video. If you have not subscribed to my channel so far, please do that. Thank you.